All right, today we're going to be looking at page 145, 9.1 video notes. We're going to be starting chapter 9 off doing a lot of square roots because we'll be using square roots for the rest of this unit. So that's the focus of this chapter, is learning how to use square roots and to kind of go back and forth. So first thing that we need to know is what our perfect squares are. So those are numbers that we can take the square root of evenly and get a whole number as an answer. So think of this as 1 times 1, 2 times 2, 3 times 3, and so on. So our first 12 perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So 144 would be 12 times 12, 11 times 11, and so on. Obviously, these numbers keep on going, but that's a good start if you have a list, so you can check if you have perfect squares when you are doing your radicals. So number one, we're going to simplify the square root of 16. If you look and notice that 16 is in our list of perfect squares, so the square root of 16 will be a whole number. The square root of 16 is 4. Number two, the square root of 50 would be just above the square root of 49. So this is what we call not a perfect square. What we need to do to simplify this is we need to break 50 up into its factors. And we want to look for a factor that is a perfect square that we can divide 50 by evenly. So in this case, we're going to break the square root of 50 up into the square root of 25 times the square root of 2. Right? 25 times 2 is still equal to 50. But 25 is on our perfect square list. So we'll do the perfect square, or the square root, sorry, of the perfect square, and we will get 5, that's the square root of 25, times the square root of 2, and since we can't do the square root of 2, we're just going to leave it like that. And so our final answer is just going to be 5 radical 2, and that's as simplified as it can get. Sometimes you'll have a coefficient out in the front, like in number 3, we'll have 2 times the square root of 36. 36 is on our list, so we can do the square root of 36, and we get 6, and now we'll just do 2 times 6 and get 12. Moving further down, we're going to work on multiplying, dividing, rationalizing, and then adding and subtracting. So first, we're going to look at multiplying. If you think about multiplication, the order doesn't really matter, so we could rearrange the order and do our whole numbers, 3 times 5, times our 2 square roots, square root of 2 times square root of 7. So the 3 times the 5 will get 15, and then our square root of 2 times our square root of 7 is the square root of 2 times 7, which is 14. We want to make sure that once we do this multiplication that this number cannot be simplified. As long as it can't, then that will be our final answer, the square root of 15 times the square root of 14. Dividing will work the same way. We want to think of it kind of as two different problems. We'll have the 10 divided by the 2 and the square root of 180 divided by the square root of 5. So 10 divided by 2 gives us 5. And the square root of 180 divided by 5 is the square root of 36. The square root of 36 is a perfect square, so that will be 5 times 6, and we can simplify that to 30. Our last process is called rationalizing a denominator. So there's a rule that we are not allowed to have in a simplified form a square root or a radical in the denominator of a fraction. So when we have one, we need to learn how to what we call rationalize and make our denominator a whole number without a square root. So the trick to doing that is we're going to multiply by another fraction. And in this fraction, we want the denominator to be the exact same number that we have over here, the square root of 2 times the square root of 2. What we then want to do is to match this number on the numerator. So if we're multiplying by a square root of 2 on the bottom, we want a square root of 2 on the top. If you think about that, the square root of 2 divided by the square root of 2, this new fraction is equal to 1. And if we multiply something by 1, we haven't really changed the number. So we're going to change what it looks like, but the value will still be the same. So what we get is 9 times the square root of 2 in the numerator over the square root of 2 times the square root of 2 in the denominator. You can kind of do this in 2 steps, or once you get used to it, you can do it in 1 step. The square root of 2 times the square root of 2 will be the square root of 4, but the square root of 4 will be equal to 2. So we end up getting what's in the square root as our whole number in the denominator once we do that square root. On the top, we want to make sure that we can't simplify that or reduce it, but 9 and 2, we can't divide that, and the square root of 2 is not reducible. So 9 times the square root of 2 over 2 is our simplified form. That might not feel like it is simplified, but we can do a lot with that as we move forward in geometry and then into algebra 2. So that's rationalizing. The next is adding and subtracting radicals. And think of this, when we talk about like terms, think of this like it was variables. If I gave you 5x plus 9x, we would say that's 14x. I have 5 of these things plus 9 of these things, and so we have 14 of these things. It's the same idea when we use our square roots. As long as the square roots are the same, we're just talking about how many of them that we have. So I have 5 root 3's plus 9 root 3's. And so if I add those together, I have 14, and they are still root 3's. Same thing with subtraction. As long as they are the same square root, 19 radical 5's minus 1 radical 5. 19 minus 1 gives us 18 radical 5. If we do not have like terms, you won't be able to subtract. So I can't do square root of 32 minus square root of 2. The thing that you need to double check and make sure is if we simplify the square root of 32, will we end up with like terms later? So the square root of 32 is the same as the square root of 16 times 2. The square root of 16 is 4. 4 times the square root of 2 minus this original 7 square root of 2. And now we do have like terms, a radical 2 and a radical 2. So 4 root 2 minus 7 root 2 would be negative 3 radical 2, and that would be our answer. Now, just to point out a different problem, if you had something like 4 radical 3 plus 5 radical 5, right? These square roots are not the same, and there's nothing we can do to make them the same. So there is nothing to do to simplify that. That would already be as simple as it can get. That would already be the answer. All right, good luck. Keep practicing your square roots.